Mark, who are you?
Yeah, so I'm Mark Abrams. I am my title is field engineer, and I always tack on edge specialist to that. Um, and I work for SUSE now, which acquired Rancher Labs back in January of this year.
I find that interesting. So, field engineer, I understand that. Edge specialist, I don't know what that is.
Yeah, so I tacked that on because I started. So I'm a field specialist. Sales engineer is another term for it,
Hmm.
um, and I basically help prospects and customers take their idea of what they want to do and do demos to them and show them sort of the art of what's possible. And it's all centered around Kubernetes and container orchestration. But what I found over the last year and a half, 2 years, was a growing interest in Kubernetes at the edge. And I'm talking about the network
Mm.
edge. There are other edges we can talk about too, but the the telcos talk about the edge of the cloud,
Hmm.
um, which is really like they have these heavy duty data centers. I'm talking about like where you can barely reach the network anymore because you're the last link. Um, so so we just started seeing more and more people interested in Kubernetes in this space in retail and manufacturing, in mobile data centers. So there are trucks that go around, but they've got fairly sizable computers on them. But maybe they're hooked up through the cell network or something, and they want to run Kubernetes in all these places. So
That's crazy.
I became it's totally crazy, and at the same time, like it's what like I started to get really interested in once it became viable. I started really playing around with Raspberry Pis and the sort of consumer accessible equipment. Like, hey, can I get Kubernetes on this? Can I deploy containers and container orchestration? And so that's how I ended up as the edge specialist. I just kind of took on the work to do it.
Now, I can never say this right. It's SUSE? Is that how you say it? Or SUSA? Or
SUSE, I think is
SUSA?
yeah, SUSE. It's actually a four-letter acronym, four words in German that I can't pronounce at all. So
We're gonna have to look that up later.
yeah, I'll send you the video link. There's
So,
actually several videos how to pronounce SUSE.
well, maybe we'll be one of those too. So, what is like? I've seen SUSE Linux. Like whenever you look at distros and stuff, like that comes up. But what exactly is SUSE?
Yeah, so SUSE started out as like this mom and pop enterprise for Linux, and Linux was released back in the 90s, and SUSE came out a couple years later as a distribution of Kubernetes, and that is where they kind of started life. They've become well, now they're a publicly traded company
Hmm.
as of like last week.
Oh wow, time to invest. Where's my?
So SUSE is primarily a distribution of Linux, or fundamentally a distribution of Linux. But of course, they do many other things. Red Hat is perhaps the most well-known open source Linux distribution, but SUSE actually started that whole concept and an idea of an open source distribution. And today, they're basically embedded. They're embedded in embedded systems that run
Hmm.
Linux. They're in your cars and a lot of autonomous vehicles.
That's
They've
cool.
got yeah, and
So,
outer
question:
space,
Is my Tesla
aerospace,
running
automotive.
SUSE right now?
Tesla, I don't know that Tesla is running SUSE right now, but that would be cool. I know that some of the luxury brands, the BMWs and Lexuses and some of those, I believe, are running SUSE today.
That's killer. Now,
Um,
so
yeah,
I know Red Hat. It definitely has the open source flavor, but you got to pay for it. You got to license it. Is SUSE like that, or do they have an open source version, kind of like CentOS?
yeah. So we have an open source version called Open SUSE.
That's right,
Leap.
OpenSUSE. I've seen that. Yes. Okay.
Yeah, yeah. And yeah, I mean, it's funny because I've known about SUSE for years. I started getting into Linux back in the late '90s when I was in school, and when you're first getting into it, at least back then, you tried everything, right? I mean, I did like Linux on a floppy, right? You could, and that was cool. I could hack into Windows systems, but uh, OpenSUSE and SUSE at the time was just another distribution. But there was Yellow
Hmm.
Dog, there was Debian, there was Ubuntu, of course, Red Hat, CentOS, Fedora, and what do you pick? And personally, I was always in the Debian sort of. I ride a fixed gear bike too, so I'm kind of like, I want the straight and narrow, just easy, like
I'm the same way.
it's
Debian all the
it's the
way.
nuts and bolts, right? Yeah. So I never really looked at SUSE, but I've been very impressed with the ability. They've got this tool called Kiwi, and Kiwi allows you to actually build the kernel and the operating system for any given device. So sort of like what you would do with an Arduino, right? You get it like a board support package, and then
Hmm.
you target a specific board. And so we've got some tooling that allows you to rapidly, basically create your own distribution from the SUSE base.
Oh, dang.
So stuff like that, it's pretty cool.
That's cool. I love talking Linux distros, and I'm curious now. Why did SUSE acquire Rancher? 'Cause, I mean, I just talked with Caleb about Rancher a lot. Why did
Yeah.
SUSE acquire Rancher?
Yeah, so SUSE acquired Rancher because we have um, some symbiotic things that we do. Um, Rancher needed an operating system. Rancher actually was not in need of cash. We were actually very well funded,
Hmm.
um, and so the opportunity with SUSE had to really really mesh for us. But culturally, SUSE is really looking at open source as the foundation. Rancher looks at open source as adoption is the key to what we deliver. Like that is if we create something in open source, we throw it at the wall and nobody uses it, then we're not going to develop it more. If
Right.
if it gets adopted, then it gets support, and so it grows. SUSE sees the value in that. So there was symbiotic relationship. We we really need a Linux operating system. Rancher will run on any Linux operating system, but we need one, so it's not a bad place to be. But SUSE really, and pretty much every organization these days, but especially Linux companies, are seeing that the next phase of distributed computing really requires container orchestration.
Hmm.
And so, we've kind of been through all the companies building their own. We've all settled on Kubernetes as like the main primary default
Hmm.
distribution or the main Kubernetes orchestration solution. And so SUSE really saw Rancher as a way to pull that into their portfolio as something that was necessary for growth. So the other thing one of the reasons they acquired, excuse me, one of the other reasons they acquired Rancher is that we are innovative. We have been. We are Rancher Labs. We don't sell any products. We
Mm, okay.
Everything is open source. Um, so so they came to us to get innovation, and we get from them distribution. So because they have a huge distribution network of who is using SUSE open source Linux, or who's using SUSE as a paid Linux, either way.
Hmm.
And so it accelerates our growth of Rancher and Kubernetes management, and it accelerates their growth and their ability to. It accelerates their ability to innovate in the container orchestration space.
Oh, totally makes sense. So right now, I know you can install Rancher on pretty much any Linux distro. So we're going to see, I guess, more tightly coupled deployments of SUSE and Rancher combined, and it's just going to be just work out of the box, I assume.
Yeah, I mean, it works out of the box today. It was funny. I mean, there was some things that SUSE had to change. We had to change in the OS to get Rancher working on it. Um, but it pretty much works. I don't know that there's plans for tight coupling of Rancher to SUSE. I mean, you'd think eventually we want to see something that makes SUSE sticky. Um, but part of what makes Rancher so great is that we don't really care what operating system you use, and we
Mm,
kind of talk about the fact that everything below the Kubernetes layer at this point is a commodity. And so SUSE can bring you value if you purchase Rancher, regardless of whether you run it on SUSE or not. At the same time, we can we can add value to if you're buying support for your Kubernetes orchestration platform and you want support for your operating system, you can go to one single place and get those. So from that perspective, yeah, there's value in running SUSE under Rancher, but it's not, I don't think there's plans to sort of drive that nail home and make it so it's hard to use Rancher anywhere else, or that
right,
you
right.
would think, yeah. I know a lot of companies do that, but so far, and this is one of the reasons I like SUSE too, is that they really kind of see the value there, as far as I can tell. So
I like that because it does become frustrating when companies try to box into where you can only use their one flavor of something, and it makes it harder to integrate it into your company. So that's
yeah,
really cool. Um,
yeah.
so what is Rancher? I mean, my audience, they would have a passing familiarity with Kubernetes. I made a video about that. But what is Rancher and how does it relate to Kubernetes?
Right. That's a great question. So Kubernetes is fundamentally container orchestration and gives software applications high availability, reliability, and scalability. It's plumbing and electrical for software apps.
I like that.
Rancher recognized early on that companies didn't just have a single Kubernetes distribution. Now, if you go to the Google route, you might build this Borg style cluster. And that was sort of, Google's claim to fame was like, hey, we just run it all everywhere, right? It's all production. Development is production, production's production, and you just need one big cluster. But the reality is that that's really, really hard to manage for most enterprises. And they're not structured to manage in that way either. They've built their data centers based around the idea of isolating production from non-production. So at a minimum, they're going to have two clusters.
Hmm.
Not only that, we're seeing that they want clusters both in their data center and they want to burst into the cloud, or they want to be mostly in the cloud, or they want to be in multiple clouds.
Hmm.
And so what Rancher brings to this equation is the ability to manage multiple Kubernetes clusters. So Kubernetes it is actually very difficult. And so there are layers of simplifying it. And the first sort of offerings that came out were these distributions. And so you've got COPS and KubeSpray and KubeADM and
Hmm.
all these different ways to get Kubernetes. And now like Pivotal, Cloud Foundry became Kubernetes underneath, right? They changed it up because what they were seeing was that the value of Kubernetes was its Legos. Now, if we're all using the same configuration style, that means I can port from one thing to another. And it's that open source mentality is
Hmm.
I wanna be able to use my bricks everywhere. If I go to AWS, I still want to be able to use my bricks. So that's what Rancher brings you, is the ability to go to different cloud providers, be on-prem, have multiple clusters, and still get the same experience across the board, and still be using Kubernetes, fundamentally Kubernetes configuration.
I love that. Now, I've used KubeADM to deploy Kubernetes. Does Rancher essentially replace that?
It does.
Okay, that's
So
awesome.
KubeADM is really a distribution of Kubernetes. It's a way to package up the 7 core executable components of Kubernetes.
It is complex.
Yeah, and then deploy them with potentially with some other assets, some networking, and DNS, and some things that aren't the core fundamental components. so that you have a working functioning Kubernetes. So Rancher provides 3 distributions that would be a replacement for kubeadm. At the same time, however, we, again, getting back to this sort of open source idealism,
Mm-hmm.
we recognize that some people love kubeadm and that's what they want to use.
Right.
And so you can still get value out of Rancher managing kubeadm clusters because you can import them into Rancher. Rancher works with any Kubernetes cluster as long as it's based on upstream Kubernetes. So
Wow.
forks of Kubernetes usually have some changes to the Kubernetes API that we can't guarantee integration with. But upstream distributions of Kubernetes, it's a consistent API. We can pull those in, and then you can do things like take the capabilities that Rancher offers, monitoring, logging, networking, service mesh, CIS benchmarking, other security aspects, OPA gateway, things like that. You can deploy those down to those downstream clusters, regardless of distribution.
Now, I know Kubernetes is great to be used in like typical microservices use cases. So like just deploying your data center, your cloud. But I never thought about it as an edge thing until I've started talking with you guys. So real quick, I guess your elevator pitch on what is edge computing?
Yeah. So what is edge computing? I guess edge computing is any compute, any processing on a computer that happens at the edge of the network. Now, I do need to disambiguate because the telcos talk about edge computing also. And for them, the edge is the edge of the cloud and has to do with physical location.
Mm-hmm.
So when I'm talking about edge computing, I'm talking about computing at the edge of the network, which might be your home or a retail store, where things pretty much come to an end. It's the leaf node of the network.
Like there's nowhere else to go. There's nowhere
There
hops.
is nowhere
You're the
else
last
to
hop.
go. You got it. You got it. It's the last stop. This is the last stop on the bus, right? But what and I have to disambiguate, as I was saying, from what the telcos talk about edge, because for them, the edge means physical edge, which is closer to where data is being generated. And that's actually very important because when we talk about edge computing, we're really talking about computing data that is being processed or produced at the edge of the network.
Mm-hmm.
And this gets into not just retail or factory edge devices at the edge of the network that can do computing, but data collection or data production like sensors, or in the reverse, actuators, things that I can make have a change,
Mm-hmm.
A robot arm, for example. So edge computing is really about doing data processing near where data is being produced today. And data is being produced everywhere, not just in the cloud, in the data center, or in the network hubs that the telcos run.
Right. And then, of course, the main benefit being that we don't have to wait for the traffic to go all the way to wherever the central location is, and that just takes forever. Latency is super high, so we need that super fast processing. Now, I'm just curious. This is what you do. What are some of your like ideal use cases for edge computing, where it's like absolutely necessary?
Yeah. So edge computing, it's funny because it's been around. Edge computing has actually been around for a long time.
Mm-hmm.
And we have to talk about sort of so I'm gonna start to talk about the far edge.
Mm-hmm.
The near edge is the telco edge, and that's the one that is more really like cloud. The far edge is the retail businesses, it's the windmills, but we've had edge computing by way of embedded systems for a very long time. And so maybe you had a clock or a microwave which had some capabilities. They had compute capability. What's really new about it is that we're connecting these things to the network, and
Okay.
there's this overlap with edge computing and Internet of Things because we're adding connectivity to all the things that already could do compute. Um, so in terms of like an ideal use case for edge computing, I, I don't know that there is one that I would say is ideal. I mean, there are some that I'm passionate about.
Hmm.
Um, I really, so automotive is very interesting for a lot of reasons. I find AI fascinating, but at the same time very scary in a sort of dystopian
Of
kind
course.
of future way.
Especially when the
Right?
guys who are like making the AI are like, yeah, we're scared. Like, you shouldn't do this.
Yeah, yeah, because we don't really know how it came to that answer, right? It's like we told it some ideas, and then it came up with an answer that we didn't think of. Wow, it's really smart, or is it? I don't know. But so so one of the things though I find fascinating, and again, trying to get away from the dystopian Big Brother type environments and trying to see, I realize it's not all utopian, but there's definitely good to be had. And for me, smart cities is one of the really interesting use cases
Mm,
because, for example, the city I live in is about 100,000 people, regionally about a million people. But we just don't do bike paths and walkways the way they do in Europe, for example, and
mhm.
especially in Holland. You go to Holland, you go to the Netherlands, and it's just like a dream world for a cyclist. And we don't do that here. And so I've been to some meetings. We have these town meetings, and the problem is data collection. Turns out these data collectors are super expensive and they're hard to place and they're insecure. And it's like, I look at that and I'm like, really? How hard could this be? I mean, I'm pretty sure I can do what you're trying to do with a Raspberry
That's
Pi.
why, like, you're probably
I mean,
thinking, I've got like 15 of these. Let's just do that around my house.
well, I'm like, can we go down to like the center of gravity? There's this tech center we've got in town, and just we'll all just bang out some devices and we'll put them around town and collect the data you need. Like, what's the problem? So, I think smart cities is one of the interesting ones. But I think also, as I said, the automotive, the aerospace, because both the automotive and aerospace are like interesting but really big challenges. For edge computing, they are edge. For container orchestration and putting Kubernetes there, um, they introduce new challenges,
Mm,
which if I was to put edge computing into a retail enterprise, um, it just feels right, and I can explain that more if you'd like. But it just works. It just there's not a lot of challenges other than just making sure that the hardware can run the software
okay.
and but it can bring value. Whereas aerospace and automotive, you've got security issues and
Hmm.
timing issues, and it's rocket science at this point. And
Yeah,
so
literally.
literally, yeah. So it's more challenging.
Okay, okay. Now, real quick, just kind of, I know you may have answered this already, but the main difference between like edge computing and then IoT, because like I've got smart IoT stuff in my house right now, light bulbs and all kinds of stuff, but I wouldn't consider those edge computing because I don't believe my light bulb has too much smarts in it beyond that it can just talk to the network.
Right. So that's a really great question. So IoT versus edge computing, there's an overlap there. And what's happening is we're looking at the areas where we already have or can place new equipment that can handle container orchestration solution that would be able to be the hub for the data produced by IoT. So your smart light bulb doesn't have the computing power to run a container,
Hmm.
maybe a container, but not container orchestration. But it's producing all sorts of data. And so it's the data collection that, why should I send that back up to the cloud, which is really the cloud is a data center. For me, it's in New Jersey somewhere, uh, you know, 300 miles away. And, depending where you are, it might be a data center in San Francisco or Cupertino or something, right?
Right.
Uh, and so really, why should I send the data all the way back there in order to process it and make sense of it? And for the home user, the the it is what it is. We don't have necessarily a lot of choice. Our Hue light bulbs do need a hub, and I
Hmm.
expect the smart hubs of the future will actually be powerful enough to run container orchestration solutions as well. Um, but for the most part, a lot of what we are doing at home, our home IoT doesn't really need Kubernetes or container orchestration. It's a toy. But when you get into industrial IoT and data collection in a field in farming, or data collection in a factory, which is usually isolated from a network, somewhere within that factory, there is a gateway that reaches
Hmm.
out to a network, and it's on a VPN or VPC or something like that. But the industrial IoT, that is where they're looking at, oh, let's take existing hardware or put new hardware in that can do all the work that we're doing up at the cloud, or some of the work we're doing up at the cloud. If you think about an assembly line, a factory assembly line,
Hmm.
and producing a widget, and when you're producing a million widgets, doing data analysis on the production process to refine that process. So the next time you produce a million widgets, you can do it faster or better or cheaper, is very important.
Hmm.
And so that's where we're seeing the IoT overlap with edge computing, is that they touch each other, because the IoT tends to be the producer for the edge computing.
So the use case of the factory there is that um, you're doing so many things that require, I guess, a lot of processing to be able to. I don't know what they're using, like AI, to figure out if they're producing the widgets correctly. And instead of doing that processing in the cloud and waiting on that data to come back and forth, which might not be enough time, they're doing it right there, fast, and possibly because of a lot of network constraints and security, it's more efficient and better to have it right there.
That's exactly right. Yeah.
So how is Kubernetes running at the edge different from in the cloud or a data center, or I guess in my house on a server?
First of all, in the cloud, the idea is to give your application workloads a sense of infinite resources.
Mm-hmm.
Um, and when I say resources, I mean CPU and RAM.
Mm-hmm.
So one of the things Kubernetes does, you guys know, is it schedules CPU and RAM. It schedules, right? When you and I schedule, we schedule time. Kubernetes schedules resources. So, so in the cloud, we want to give the sense that we have infinite and unbounded amounts of CPU and RAM. So if I need to scale up because my process needs more, go for it.
Mm-hmm.
And AWS makes us empowered by giving us that sense. Of course, our pocketbook suffers, but if we want to feel like we have unlimited resources,
Yeah.
they'll give us that ability. At the edge, we have, on the one hand, we have smaller devices. It's not always the case that we have smaller devices. There are situations. So at the edge, we have situations where we do have high performance compute, but it's isolated. It's isolated on the network. And so we have the power, the CPU and RAM, but we have, maybe less physical resources. So maybe I only have one server, or maybe I only have two servers. And two servers is good for HA, but if you know Kubernetes, for stock Kubernetes, you can't do HA with two servers. You need three servers.
Mm-hmm.
And so how do I get high availability? Then the question you have to ask is, do I need high availability? In many of the situations at the edge, it's not even a requirement, because the 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 processes that are accessing the compute are not, while they do expect a certain time bound response,
Hmm.
they maybe can accept some sort of failure and time to recovery. So a single node cluster at the edge is actually not uncommon, because the cluster can just be restarted and services rebooted. Kubernetes, of course, allows you to have stateless services that, once you turn them on again and they're running and everything runs,
Hmm.
no problem. So your cluster in Kubernetes, we talk about ephemeral services, workloads. At the edge, we talk about ephemeral clusters. And even in the data center, we talk about that somewhat. But the idea that, if I have a retail store and they run perhaps two clusters, and we can talk about the architectures for that if you want. But let's say they're running two clusters, or they're running one and they have a backup just in case. Um, Another alternative is just to ship them a new server. So the devices are getting so cheap. Think Raspberry Pi, think NUC.
Hmm.
Um, that I can just have them overnight them a new server that has everything they need. If the thing goes down, just send it back to the warehouse. We'll figure out what's wrong with it, because what we're lacking at the edge is technical skill sets that we have in the data center. There's nobody there to service the thing.
Right, right.
So
You don't want that
I need
barista
these.
going over there deploying containers. Yeah.
Right. And if you don't want to do sneaker net for 10,000 devices,
Hmm.
you need to be able to just trash them. So Kubernetes at the edge has some different constraints around the cluster itself, around how you build the cluster, but it also has the fact that we have all those additional resources. What do I mean by additional resources? So CPU, RAM, standard. GPU is becoming standard. It's capable. Kubernetes now allows you, I think, since 112, version 112 of Kubernetes, you can just go access some GPUs somewhere. If,
Oh, I
if,
didn't know that.
if the underlying system has the capability, you can do it.
Oh, so maybe some
Yeah,
Bitcoin mining here soon.
yeah, absolutely. So you can run your blockchain on your GPU in your Kubernetes cluster now. Um, but the other thing that happens, and for those familiar with the Raspberry Pi, um, I've got 40 GPIO, right? I've got USB ports, I've got HDMI, and then the number of things that I can plug into that system is really, it's not infinite, but it's unlimited. There's I mean, and people are coming up with new things every day.
Hmm.
So it's possible to have a Kubernetes cluster that needs resources that are plugged into an edge compute device that don't exist in the cloud. You would never even see them in the cloud. So now I've got to
Mm.
surface those resources up to Kubernetes, my Kubernetes cluster. And then the other way to do it is to feed the data. The data from the resource could send it through a standard like MQTT or some sort of a message bus.
Hmm.
But sometimes it's just the device itself is the thing that's hosting those resources.
Why not just use some other container resource like Docker, running one, two, three containers on the edge instead of doing this massive orchestration with Kubernetes?
Yeah. And it does beg the question, like, is this too heavyweight for an edge device? And for an individual device, it might be. And IoT already has adopted containers. So if you look at Balena, or you look at Losant, you look at Horizon from Toradex, pretty much all of the small hardware vendors that that are producing the core of the IoT solutions. They're producing the hardware of the IoT solutions, or they have some cloud enablement of an IoT solution. All those companies have container offerings today, and they've been around for quite a few years with container offerings.
Mm-hmm.
What we're seeing is a move to the container orchestration. And the reasoning is that it allows you to separate the embedded system aspect of your hardware from the application aspect. So there really were two paths. There was the sort of embedded systems, and then what we could do is we could put a container runtime on the embedded system, and you can deploy containers.
Okay.
But really what we want is container orchestration, because we want consistency in process from the cloud to the edge. Because the same engineers that are producing the apps in the cloud should be able to produce the apps at the edge if they know what resources they're accessing. We get into that standard configuration and the idea of Lego building blocks.
Mm-hmm.
So if I can create a device that allows you to have the fundamentals where all you need to do is give me a Kubernetes YAML to deploy, now I have a system that fits into everything else you do in your enterprise. And so it's sort of an enterprise-ready solution to have cluster orchestration from cloud to edge.
Now, as far as like the adoption of Kubernetes and edge and IoT, what are the market trends you're seeing with all this?
Yeah, no, it's pretty huge. There's actually a lot happening. I mean, there's a blog out there. There's an article about Kubernetes running on U2 spy planes. We have reports of it running on some land equipment for the military as well.
That's cool.
We know that it's running in, like Chick-fil-A has some articles about how they just deployed Kubernetes into their stores, and they have thousands of stores, right? And so that all of those stories are happening not just in the people that are telling the stories. They're happening in the big box stores, the Targets and the Walmarts. They're happening in the retailers that, everyday retailers. They are happening in energy. We have energy companies coming to us with rigs that are either land-based mobile rigs that they want to put container orchestration on, or they're potentially seafaring. We're seeing it in shipping and the physical container
literally
industry.
Containers.
Literally, yeah, where they need to keep track of literally physical things that are being shipped across the water, and so we are seeing it everywhere. We're seeing interest in automotive. We're seeing in factories. So I don't know where it's not touching what we do today, and the the numbers for the predictions about the number of devices at the edge, I'm sure you've heard, is in the billions.
Oh yeah, it's crazy.
Yeah. So there's just a general explosion of edge, and then there's some acknowledgement that container orchestration helps with that. There is a piece too. So as I mentioned before, Rancher is a multi-cluster management solution.
Mm-hmm.
If you're managing 4 clusters in your data center or your clouds or whatever, that's one thing. If you're managing 10,000 clusters, you absolutely need a tool to do that. There's no way you're gonna manage that through infrastructure as code alone. And you can write your own tool as well, but there are tools out there that exist like Rancher and Fleet.
I did want to talk about what's running on this guy, K3S. What the junk is that? Because we all seen K8S, Kubernetes, but K3S is just smaller. What is that?
Yeah, it's just smaller. That's exactly it. So it is a little bit of a play on words. So Kate's K8S is Kubernetes, and then there was some trend. There's actually a word for it, and I can't remember what it is. But you take the first and last letter, and then the number of letters in between, and that's the number you put in between those two letters.
Ah,
So if you
okay.
count the letters in Kubernetes, there are 10 total, but we don't count the K and the S. K3S is lightweight Kubernetes. So we slimmed it down, and I forget what it was, a play on the term K. It doesn't really mean anything. But what is it really? What is K3S? So K3S is Kubernetes. It is a distribution of Kubernetes.
Hmm.
How did we arrive at this distribution of Kubernetes and what makes it lightweight? So you have to look at what makes Kubernetes heavyweight to begin with. And what that is cloud providers and storage for the most part. Um, the way that Kubernetes grew organically is that when the cloud providers came along and said, oh, we want in on this, we have some specific things that we would like included in Kubernetes. Then the Kubernetes team said, okay, go to this source tree and under vendor, put your stuff. And so they put it in the source tree. And they did that for all the cloud providers. There's a lot of cloud providers. I mean, we think of the big three, but there's,
Oh.
there's Linode, there's DigitalOcean, right? There's
Mm-hmm.
Equinix, you got a ton. So, and then there's all the ones that aren't US based too. Well, they all wanted their stuff in Kubernetes. So that actually, even if I use the cloud, I'm only going to use a few cloud providers. I don't need all of that. So we stripped that stuff out. Now, it turns out you can put that stuff back in because Kubernetes, the project itself, realized that this was getting too bloated. And so what you can do is actually there is a cloud provider option. You can add back in the cloud provider bits with a flag to the kubelet, I think it is.
Okay.
Maybe I think it's to the kubelet that you add the flag to get the cloud provider stuff back in. Turns out the same thing happened for storage providers. There's there's probably more than 50 now, but there's all these storage providers, and all their stuff is in the source tree. And when we were looking at Kubernetes, this lightweight Kubernetes, what actually happened is our engineers were developing. We throw stuff at the wall all the time. So we just, hey, what if we try this? So we're trying to build something that makes development easier for developers, and that tool is called Rio. That's what we were working on at the time.
Rio. Okay.
And the developers, yeah, RIO, and it's kind of a tool that's like, tell Kubernetes I want a canary deployment with this percent canary and the other percent regular, or I want a blue-green deployment, right? So stuff
Mm-hmm.
developers do. So anyways, that project, as they were working on that, they were like, as they're working with Kubernetes, they were like, it's painful. There's so much, it's hard to build. It takes a long time. What if we strip all this stuff out that we don't need? And so they started pulling stuff out. And then they actually went so far as pulling out all of the alpha features and the beta features, which you are not enabled by default in
Oh.
Kubernetes. You have to turn those on. So we pulled all that stuff out. Later on, we realized there were some things in the beta features like pod security policies, which now those are going away anyways, but people wanted those turned back on. So we added back in the beta functionality, but pretty much anything can be turned on with flags in the kubelet or the scheduler, the API server, whatever you need to turn on.
Mm-hmm.
But we stripped a bunch of code out, built it into a single binary. So now your distribution is just a runnable Linux binary. And so it's both slimmed down in terms of the amount of memory it uses, as well as the way you install it just is extremely simplified. We didn't necessarily target the edge. Like we weren't building it saying, oh, we're going to tackle Kubernetes at the edge. We built it saying, this is a problem that needs to be solved. And then the edge came to us and said, whoa, like people like me were like, whoa, I want to put Kubernetes on my Raspberry Pi. And people just started using it in that way. And so it became refined for the edge use case.
So, I mean, so what you just said, it wasn't developed for the edge, but it's a perfect edge scenario because it is super lightweight, doesn't have anything you don't need. What was it kind of like? I mean, because I would assume that they were doing Kubernetes on the edge before K3S. Now, who developed K3S? Was it you guys?
Rancher Labs.
Wow,
Yeah.
so it was actually Rancher Labs that developed K3S. Okay, I didn't know that.
Yeah. So it came out of Rancher Labs back in March of 2018, maybe 2018, I think it was.
Okay, that's killer. That's awesome.
Yeah,
So,
I was in like a company meeting where they announced it internally, and I was just like, I was over the moon. I was like, you guys, this is amazing. This is incredible, and and that's when they were like, okay, Edge guy, go ahead.
put it on all your stuff.
Run with it. Go for it. Yeah.
So like, but I mean, obviously Edge's been around before that, so I assume they just had to deploy full Kubernetes or try to strip stuff out as best they could, but it was just bulky and slow, I would assume.
Yeah, I think the main distribution for Kubernetes at the edge prior to K3S was called Hypriot. And that's still around. I still see some people using it. But I don't know about in production. Work with some hobbyists that I know are using it, and maybe it's familiarity. I'm not sure.
Mm.
And then the Ubuntu had was it Ubuntu MicroK8s?
Yes,
I think
yes.
was from them,
Mm.
and that was like a developer version of Kubernetes. And the reason we call it a developer version is because you could only install a single node cluster. You couldn't do larger clusters. And so one of the goals with K3S was to make sure that you could do production grade clusters. After the fact, MicroK8s said, oh, you know what, we should do that too. There was another one, Minikube, maybe it
Yes,
is.
yeah.
Yeah.
Mm.
So those were your options: Minikube, MicroK8s, and Hypriot. Um, and I think those all precede K3S, but K3S did the work to make it a full-on Kubernetes distribution that could be a high availability cluster, as well as to get the CNCF certification. So,
Okay.
so the Cloud Native Computing Foundation recognizes K3S as a certified distribution of Kubernetes.
Okay, right now, can you deploy K3S like as a service anywhere on a cloud provider? I mean, I know there's EKS and they have their own flavors, but do they just deploy K3S at all anywhere in the cloud?
Oh yeah. We're working with a bunch of the cloud providers where they're using K3S as part of their images. There are there's this one project. What is it? Civo? CIVO, I think it is. Something Alex Ellis put together. I think he's actually like leasing time on Raspberry Pi clusters that are running K3S.
What?
Um,
That's
yeah,
awesome. I need to
it's
try
like
that.
a cloud of Raspberry Pis. Uh,
Oh my gosh.
Super interesting. Yeah.
So speaking of which, I mean, I know K3S can go on Raspberry Pis, but I'm going to tell everyone about this. Where else do we see like edge? What other type of devices are on the edge that you would run K3S on? I mean, we talked about Raspberry Pi, talked about NUX. What else are we seeing?
Yeah. It, would it be all right if I share my screen for a moment?
Yeah, go for it.
Your question was what can I put Kubernetes or K3S on besides a Raspberry Pi? And the answer is pretty
Mm-hmm.
much anything that runs a Linux operating system. So I'm building this Edge Cyber Deck, and hopefully this image will clear up a little bit. Maybe this is a blurry one. Let's see if we can find. Here we go. Here's a less blurry one. So this is a bunch of. So in the center here, this big board is actually a bunch of Raspberry Pis. Is a Turing Pi with seven compute modules on
Yes.
it. But next to it with the fan, that is a Jetson Nano. That is a NVIDIA GPU board. It's their dev board. We are seeing in production requests for and use of the Jetson Xavier, which is a related device, but it's the industrial, it's like the industrial model of this hobbyist device. Everything in here is running K3S, except that Arduino down at the bottom there. That one's not running K3S, but I'm using that as a producer, a data producer. And so the data producer, let's see, I want to zoom out here,
This is so cool.
is actually connected to this robotic arm, which is this is my sensors and actuators, right? And
Oh
then
my
the
gosh.
clusters, this kit is basically my edge kit that I'm building, is to do things like demonstrate. Here I can run a robotic arm. Here I can run a camera and do AI. I can do AI between the camera and the robotic arm, right? Like the arm mimics what you're doing, or we can play rock scissors paper, and the AI is going to try and guess what you're going to throw next, or things like that.
That is too cool.
So, anything that runs Linux, it could be a NUC. These are all ARM based, but it could be Intel based. Um, right now, K3S runs on ARM and Intel devices. And we'll be following closely the ARM version 9. So it will run on ARM version 9 as well. And I've been talking to my colleagues about what else can I put into this kit that really demonstrates sort of the edge use cases, the power of Kubernetes, and kind of geek out about some of this stuff. So.
Oh, that's amazing. Yeah, I still need to get my hands on a Turing Pi. I looked at one point and the boards were out of stock, but man, that is super cool.
Yeah, and with the chip shortage, I don't know what's going to happen, but yeah, they're supposed to produce a version 2 of the Turing Pi. And they've told me that it's going to maintain the same form factor, which is a mini ITX form factor. And so my goal was to design this CyberDeck with the idea that I could just swap out for the version 2 board, or build a second case, and all my parts would just fit in the same way.
So with edge deployments, what's the kind of scale we're seeing? We've kind of talked about a bit about like industrial situations, but are we seeing like cities deploy this, or I don't know, what are the other use cases where it's kind of massive?
Yeah, you think of cities as being massive, but right now the massive scale is coming from retail and industrial. So we have a customer that produces electronics equipment, and they have factories all over the world, and they are beginning to install Kubernetes as a gateway into those factories, but they're looking at where Kubernetes fits into what they call the line, which is the assembly line itself. So at the end of the assembly line, there's an edge compute node, and that node either is a gateway or feeds up into a gateway, which is more powerful. But they're looking at from that edge compute node at the end of the factory line, all the way down the line, what could potentially have enough compute to take on Kubernetes and container orchestration. And the magnitude, when you think about the magnitude of this organization, with, I think they've got 10 factories around the world. They've got like 7 buildings on average at every factory. They have like 10 lines in each building or something like that. The numbers just grow really quickly. Or you look at
What's an example of a device that would like run the compute? Would it be like I'm trying to visualize like in the factory on one of those lines? What would it be?
Yeah, so I mean, they have robots there. These are large robots. So they actually have a lot of computing power in the robotics. Um, and they're looking at, would they want to put some sort of a Kubernetes containerization component into those robotics? In some cases, they custom build those robots for every time they rebuild the line, they'll rebuild the robot. Like the whole line gets rebuilt. And sure, it's from a stock set of parts that they have, and they have a process for doing it. But for them, adding in container orchestration would just be another building block, another Lego in the system that they have to manufacture. And then it would allow them to feed data directly from that robot, or process data directly on that robot. They wouldn't even have to send it up the line to the gateway. They could do it right on the robot. The robot could know that it's off by a millimeter before it even gets off, right? It's got a squeaky gear or something like that, right? Because the audio sensor told you so, or whatever it is. So really, really, really interesting and complicated. We're seeing it at a large scale in healthcare. Um, so if you think about scanners, so X-ray scanners or CAT scans, or things like that. Um, if you've ever had one done, you go in the room, you get in there, and it takes 20 minutes, and the technician is both running the computer and the machine, right, the robot that is scanning you, as well as analyzing, doing like a preliminary analysis of the output of the data that he's collecting or she's collecting.
Right.
So if you were to put some AI, like a Jetson Xavier, in there, you could actually do some of that analysis on the fly faster than the technician. Like by the time the technician's done taking the picture, it's already been processed for analysis. And then you think, the magnitude of hospitals. Again, a hospital might have 6 or 7 of these machines, um, or they might, of various types. They might only have one, but they're all across the country, all across the world. Um, retail is huge, because independent retail stores, fast food chains, number in the tens of thousands, and they're putting anywhere from a single node cluster to a 3 node cluster in the stores if they don't already have them. And so we're seeing magnitudes of like um, 10 to 100,000 clusters deployed by a single, yeah, by a single like operation, in order to manage their future operations.
That's insane. Which I guess leads us to like, I know Rancher helps you manage Kubernetes, but something that large, you probably wouldn't want to just use base Rancher. So that kind of goes into Fleet, which I've heard mention of. What is this Fleet thing? You've kind of talked about it just a little bit here so far, but what is Fleet?
Yeah. So right. So Rancher was designed to run up to a couple thousand clusters with our sites on data center and that data center use case. And then with the growth of the edge computing and the growth of Kubernetes at the edge, um, we started to talk about how to manage that magnitude, that scale of tens of thousands of clusters. And so we built a tool called Fleet. Again, this came out of Rancher Labs, and it's open source. You can download the same bits that you might pay support for. You can download for free. Um, this is really, it's a GitOps tool, and it works in 2 ways. You can either use it with Rancher, which gives you a UI over the Fleet capabilities and the ability to point the Fleet manager at a Git repository, which it then, anytime there's a code commit to the Git repository, and of course this would be your production repository. So you might also be doing this on, right, the thing about the app lifecycle, you got dev, QA, staging, production, and maybe a couple other environments. Each one of those in the data center is a Kubernetes cluster. Each one of those also has applications that are being deployed through some, the future is, if they're not doing it today, it's a GitOps process where I commit my code and all of the testing and checks and validation, the integration testing is all done. As soon as that code commit hits, it's done. If it passes, I can move it up to the next app lifecycle. And so what Fleet can do is it can watch one of these Git repos or many Git repos, and it can bundle up that application ready for deployment to a Kubernetes cluster. So, so it creates the, it takes whatever you've created for Kubernetes, your Kubernetes configuration or your Helm chart, and packages it up with overlays targeted at 10,000 clusters. So now those 10,000 clusters, as they check into the Fleet Manager, they say, hey, do you have any updates for me? And it says, yep, I have this new bundle of software, and it's been customized just for your use case. So if I have geolocated differences, let's say I've got different pricing sheets that need to go to a store in Texas versus one in New York, then I could have those bundled up in a config map in Kubernetes. Fleet would automatically recognize that the bundles are a little bit different. It would build the right bundle for each store or for each region, and those would go out, basically when the cluster phones home and says, I'm ready for my updates. So we're taking SneakerNet out of it and making it so that, Fleet can help you manage all these things. Of course, you could deploy stock things like monitoring, logging, benchmarking, things like that as well.
That's awesome. So how do we get our hands on this? Like, I know you talked about it being open source, Rancher, K3S, Fleet. How can we play with that? And that's one big thing I try to give my audience is a chance to just get their hands dirty.
That's great. And so the main spot for all this is the open source code is at github.com/rancher. And you can find all of our projects there. There are some 400, maybe it's 500, I forget it's in the hundreds of projects. The majority of them, like I said, we Rancher Labs, right? We just produce stuff, and we look at what gets adopted and what's interesting. And so the useful stuff tends to bubble to the top. But any of these things we've talked about, so github.com/rancher/fleet or /rancher/rancher, you can easily, or /K3S. Now, some of these tools have been even contributed over to the CNCF. So if you go to the GitHub link, you might find that it actually routes you to a CNCF project. We've basically donated them as projects to the open source community.
Oh, that's cool.
Yeah.
Wow.
Yeah. So we're heavy into the idea of that, the community should own this stuff.
Excellent. Well, man, Mark, I think we covered everything, and this was awesome, amazing. I guess any closing words on Rancher, Fleet, or K3S, or anything you want to leave off with?
No, it's great to meet you, Chuck, and to talk to you. I think, the thing that I like to tell people is, if you want to get into computing, if you want to get into Edge, you can do all this through open source, and I contribute to open source, and you can too. It's really, there's so many ways. You don't have to write code. There's so many ways to contribute. So consider, not just consuming projects, but giving back and being a part of that community.
Well, so that's interesting. So I'm just going to ask
Sure.
this one last question. So how can you contribute to open source without knowing how to write code?
Yeah, that's so a lot of people don't realize it, but the reason that open source works is not because somebody wrote great code. I mean, that's part of it. It helps, but we have to also build communities around the code we write, and come to sort of a shared understanding about what's important. And so there's a lot of really good documentation that has to be written. I'm sure you've heard the term read the fine manual. And it helps if the manual is fine as well. It's really got to be well written. And so we need people to find bugs. So there's the quality control, quality assurance aspects of it. Just playing with stuff, finding problems, saying, "Hey, I think this looks like a bug. What do you guys think?" And I'm not qualified maybe to fix that bug, but I found it and I can report it. Or the documentation is wrong. Well, you know what? I have the power to change that. I can make it better. Um, and so that's really how open source works. That's how the open source communities work, is that we have a lot of people that come together. And I'm fortunate that I get paid by an open source company to do what I do. That I get to work in the open source environment and also take my paycheck from that. But I was a strong believer of open source prior to joining, right? And so it goes both ways. As you contribute, you find, oh, look, I got some job opportunities because of what I was doing anyways. So that's what I would say is, just go look at the project and look at what people need. There's a ton of stuff.
I love that. I love that, man, and that's so cool because I've been guilty of just being a consumer of open source, and I'm a big believer in open source, but it never occurred to me that you could just contribute in alternate ways without being a crazy awesome coder. That's cool. And then, like you mentioned, it opens up doors. Once you start giving back to community, especially in tech, when you give back, it ends up coming back to you, especially if you really work at it and do some good work.
I agree. Yeah.
All right, Mark. Well, man, that's all we got. I don't want to keep you too long, but dude, this has been perfect. So awesome.
Great talking to you, Chuck. Have a
Yeah,
good weekend.
absolutely, man. Well,
All
thanks, you
right.
too.
Cheers.
Take care.